Hello, welcome to Tutors. If this is your first time of coming to our channel, please do hit the subscribe button and also hit the notification bell. Now, we're going to be treating the topic set. Now, this is a foundational topic for set, so it doesn't require you to have any prerequisites for any of the maths topic. So, as you can see listed below, it's what we are going to be studying in this topic set. So the first thing we're going to be discussing about is what is set, and secondly we'll be talking about the properties of set. Set has several properties, and the third thing we'll be discussing is the intersection, union, and complements of set. These are also features of a set. So for you to be able to successfully solve a question under set, you need to know it. Then also we'll be discussing about Venn diagrams, how to represent sets on Venn diagrams. We'll be discussing about using the 2 circles and also using 3 circles to represent sets on a Venn diagram. Now, we're going to be solving a whole lot of questions on set. I think we are going to be solving close to 15 to 20 questions on set, including multi-choice questions. So if you stay with me through this video, you are going to get everything. Okay, so let's get on. Okay, the first thing says, what is a set? A set is a collection of items. A collection of items. It could be the shoes in your closet. It could be a collection of cars in a particular compound. So whatever, as far as you can relate to a particular set of items, you can call them a set. And these items are described as the elements of the set. Okay, so all the elements, if you say the shoes in your closet are a set, then all the individual shoes are the elements of a particular set. Now, for instance, we have heads to be equal to odd numbers, 0 and 10, odd numbers between 0 and 10. Now, you understand that odd numbers between 0 and 10 includes 1, 3, 5, 7, and 9. So you can say 1, it's an element of this particular set, heads. 3 is an element of this set, heads, and so on. So all the elements listed are this. All the items are the elements of the set. Okay, so now properties of a set. Now a set has several properties. One of them we're going to be discussing about is the equal set. Now 2 sets are said to be equal if they have exactly the same elements. Now I'm going to give you an instance. For instance, if we say A, which is a set, has the numbers 2, 4, 8, and we say B has the numbers 8, 4, 2. Now, when you compare both A and B, yes, you can understand that the same set of elements are repeating itself, except for the fact that they were not arranged in ascending order. Yes, in A, it was arranged in ascending order. In B, it's in descending order. But the elements that is in A can be found in B. So when we have this kind of condition, we say A is equal to B. So in this kind of condition, you say the sets are equal. The next one we'll be talking about is the empty set. Now, a set is said to be empty. Just like when you solve a maths question and you get 0, in set, we don't connote our answers as 0. So we connote it as an empty set. And a way we represent an empty set is by using the symbol that. Or you can also use a bracket, a parenthesis that has nothing inside. So when you do this, you say this is what? An empty set. So there are several questions that we're going to be solving that would show us how we're going to get an empty set. So when you don't have anything in the list of elements, like the items are empty, then you say you have an empty set. Okay? So some of the properties we're going to be talking about includes the finite and the infinite set. Okay, so the finite set, in a finite set, a set is said to be finite if all the elements can be listed. Yet, now, there are some list of sets where you might want to list all the elements and state them down in your book. For instance, let's say A contains even numbers. If we say A is even numbers between even numbers from 0 to 10. So you know that A is going to be 2, 4, 6, 8, and 10. So these are the even numbers that can be found. So you can see that this is a finite set. We can list all the elements. For instance, if we say A could be all the prime numbers that are less than 100. Yes, we can count all the prime numbers that are less than 100. Now, if we're talking about infinite set, a set is said to be infinite if the elements are unending or unlimited. For instance, someone can ask you, can say A is equal to all even numbers. Now, I can tell you, if you want to list all the even numbers, you're going to get tired, and you can't even do it because it's unending, it's unlimited, it's infinite. So for the fact that we can't list this, so we are going to say this is an infinite set. So to list this, we're going to write 2, 4, 8, 10, 12, and so on. So this is what we call an infinite set. So it is unending. Okay, so the next thing we're going to be talking about is a subset of a set. Now, for instance, if you have U, let's say U is a universal set, and U contains 1, 2, 3, 4, and 5. We have our A to contain the even numbers, which are 2 and 4, and we have our B to contain the odd numbers, which are 1, 3, and 5. Then we can actually say A and B are subsets of U. So U is the parent set, A and B are seen as the child set. So we connote the term subset as A is a subset of U. Then B is a subset of U. So that can be found in U. So that is why we say it's a subset. So U is a parent set, A and B are the child set. Okay, the next one we'll be talking about are disjoint sets. Two sets are called disjoint if they have no element in common. So when there is nothing in common between the two sets, you say they are what? Disjoint set, or they are not equal. Okay, for instance, we have the set S, which it's 2, 4, 6, and 8, and we have T to be 1, 3, 5, and 7. As you can see, there is nothing common between both of them, so you can say S and T are disjoints. So they are disjoints. Okay, so that'll take us into intersection, union, and complement of a set.